Hi everyone, my name's Sarah Beth Mullins. I'm a senior simulation specialist here at Treble Technologies, and I'm going to take a couple minutes to discuss an upcoming beta feature, which I'm personally quite excited about, which is our audio scene generator. So we've been talking a lot about the use of the Treble SDK as a part of a product development workflow, it's important always to keep in mind that the products that we design, the algorithms that we develop, are going to be more often than not deployed into a complex acoustic environment rather than a simplistic one. So, of course, if you want to evaluate the device that you're designing or have more rigorous data to develop your algorithms with, there's sort of been two ways, traditionally speaking, to go about developing that data. So the first one is the fully analog method, where you go out into the real world and you measure those environments yourself, which can be very expensive, be very time and labor demanding, and you don't have as much control over the actual signals that you're recording or precise information about what you've recorded in the same way that you might if you simulate this complex scene. So on the traditional way of simulating the complex scene, of course, you can take your audio files and your impulse responses, but this might end up being a multi-stage process with multiple computer programs involved, multiple repositories, and assembling the data into a usable form with all of the information required can be a bit of a faff and can also be a little bit difficult in order to keep a handle on all of the information required. So the Treble Audio Scene Generator is our attempt to help solve this problem, so we don't have to continuously reinvent the wheel when it comes to this particular issue. As you can see on this slide, the core of the scene generator are two types of collections. The first collection is an audio collection, which is the dry audio signals you'll use inside the creation of this data set. And these can be sourced from a directory with WAV files on your local disk. This could be internal Parquet files. You could be pulling something open source, such as from Hugging Face. As long as you have the audio, you're good to go. And then on the other side of things is the impulse response collection. And this IR collection is a Treble object, which we've talked about a little bit already. This IR collection, likewise, can be sourced from a number of places. You can create and simulate the rooms yourself if you want complete control over the acoustic environment. You can pull an IR collection that was prepared for you by someone who specializes in acoustic simulations within your organizations, or of course you can purchase a data set from us directly. But as long as you have that dry signal and that IR collection, you can combine them in our scene generator using a set of metadata with conversation rules, with device-specific details and listener rules, and in that scene generator, we handle all of the issues of sequencing, of preserving the information about what is being said when, where, and by whom, and where they are saying it with relationship to the device that is listening. So that was a theoretical walkthrough, but of course it's interesting to see what this looks like in practice. I have here a pre-rendered audio scene that we've created to show the classical cocktail party effect. In this scene, we have a complete bar with many human speakers inside, as well as a loudspeaker system in the corners. And we have a receiver here who is facing directly towards the back of the bar. And we have a target speech signal, which is here in the left ear of our device. If we were to render this traditionally using a simple impulse response and signal, it would sound something like this.
The increase of rents is due to two causes.
Of course, that's fine if you're looking for a clean signal oralized inside an acoustic environment, but if you want to hear something a bit more complex, we can simply unsolo this track and listen to the entire scene.
The increase of rents is due to two causes.
And it was over these curves that Grace had.
So the way we create this is relatively simple. The very first thing we do is we fetch an IR collection. In this case, we're fetching it from our data set. And we're taking a data set of 20,000 impulse responses in order to use it in our scene generation. We're also going to grab two audio data sets, one from Hugging Face. We're going to load the LibreSpeech data set, And the second one is going to be a local set of music files for use in the background. Once we have loaded the audio data set, we will then go ahead and create our set of scene rules and source group rules, which will govern things such as the overall volume range allowed in the scene, whether or not our speakers within the scene are going to be polite and take turns talking, or if they're going to talk over each other. As you can see, we have a number of presets. And once we have defined all of these, we are then going to grab a device. In this case, it's going to be a Kemar dummy head. We're going to add some noise to the channels to imitate the same measurement noise that you would expect to see in a realistic scene. And then we're going to define an orientation of the listener. Once we've done that, we can generate the scene and plot it and see the following. Now, I've actually been a little bit cheeky here because I've rendered this using the advanced features, which will be coming soon, released as the feature becomes mature. But here you can see that we actually have a source that is moving, and you'll notice one additional thing as we listen, which is that the receiver orientation is going to automatically update as a function of who is talking close to it. So let's go ahead and listen.
Miss Chester told Miss Kane the other day, and that his followers would lose a throne.
Of course, this all is very cool, but it's less useful to be able to generate these one at a time. So we have also included the ability to generate these in bulk. In this instance, I'm going to be creating 250 scenes. And as you can see, we're already moving quite quickly through the possible combinations within this room. It will, of course, take a few seconds because we are randomly and stochastically assigning these various properties following the rules. But once we're done, we're going to have a complete set of metadata files that show the individual information for each of the scenes that we've generated. As you can see here, we're looking at sort of the top-level summary of all of this information. And at this point, we could either proceed to render these scenes directly into audio files and save them as outputs, or we can save these recipes into a Parquet file for later use. Thanks so much for your time and attention. I hope you enjoy the rest of the webinar.